Hi everyone, in last video we have gone through the concept of Rolle's theorem and its geometrical interpretation, and in this video we are going to solve few questions on this Rolle's theorem. So here is just like a quick revision that what's actually the Rolle's theorem is. If a function f of x is defined in the closed interval a comma b such that the first condition is f of x is continuous in closed interval a comma b, and the second condition is f of x is differentiable in open interval a comma b, and the third condition is f of a is equal to f of b, then there exists at least one point and c in a comma b, that is a less than c less than b, such that your f dash of c is equal to 0. Firstly, it should be continuous in the closed interval a comma b, and then it should be differentiable in the open interval a comma b, and then your f of a should be equal to f of b. Only if and only if these three conditions are satisfied, then there will be at least one point c which is in between this a and b, okay, which is in between this a and b. This is what Rolle's theorem is, and now we are going to solve few questions. And now coming to the first question, verify Rolle's theorem for the function f of x is equal to x square minus 4x plus 3, which is defined on the closed interval 1 comma 3. Here what's our first condition? It is f of x must be continuous in the closed interval 1 comma 3. I'll write for the first question neatly step by step. Okay. Since your f of x is a polynomial function, it is continuous in the closed interval 1 comma 3. See, whenever you get a polynomial function, it is a continuous function. This is because what does your continuity say? That is limit f of x when x tends to a, that limit value should be equal to f of a, and that will be satisfied for every polynomial function. That is why whenever we are given with a polynomial function in the question, that is if f of x is equal to like something like a polynomial function, then we'll write our first step as, since f of x is a polynomial function, it is continuous function, hence it is continuous in the closed interval, and that is continuous in the closed interval 1 comma 3. And now coming to second property, that is it should be differentiable at open interval 1 comma 3. Now let us see whether this f of x is differentiable or not. That is your d by dx of f of x, which is equal to d by dx of x square minus 4x plus 3, which is nothing but f dash of x, which is equal to 2x square minus d by dx of x square, that is 2x, minus d by dx of 4x, which is nothing but minus 4, and d by dx of that constant, that is derivative of constant, is nothing but 0. And our third condition is your f of a should be equal to f of b. Now here your a is 1 and b is 3. Now your f of a, that is nothing but your f of 1, which is 1 square minus 4 into 1 plus 3, which is 4 minus 4, which is equal to 0. And now coming to f of b, which is nothing but f of 3, which is 3 square minus 4 into 3 plus 3, which is 9 plus 3, 12, minus 4 into 3, 12, which is nothing but 0. Here, since your f of a is equal to f of b, and the function is also differentiable and the function is also continuous, here you have to write this point, that is f of x is differentiable in open interval 1 comma 3. Okay, and since these three conditions was satisfied, our next step is, then there exists at least one point c in a comma b such that your f dash of c should be equal to 0. That means you have to equate your f dash of c to be 0. Here what is your f dash of x? It is nothing but 2x minus 4. Now what is your f dash of c? Instead of x you have to substitute c. Okay, that is 2c minus 4 is equal to 0, which gives you 2c is equal to 4 and c is equal to 2. This c is equal to 2 is in the interval of 1 comma 3, right? It is, this 2 is in between 1 comma 3. Hence our Rolle's theorem is verified. So therefore Rolle's theorem is satisfied. This is how you solve you solve the problems of this Rolle's theorem. And now coming to the second question, it is also very easy. Here you are provided, that is f of x is equal to sin x. Since we know that sin x is a continuous function, as if you can see the graph of the sin x is in this way, that means it is always continuous, there is no breaks or no gaps. So from that we can conclude that sin x is a continuous function. So it is our first step, which is satisfied. And then coming to the derivative, that is d by dx of sin x, which is nothing but cos x. That means it is also having derivative. That means your second condition is also satisfied, and your third condition is to check whether f of a is equal to f of b or not. Now f of a, which is nothing but f of 0, that is sin 0, which is 0, and f of pi, which is sin pi, which is also 0. And since these both were equal, these three conditions were satisfied. Now you have to check whether your point C belongs to this region or not. Since this is your f dash of x, which is nothing but cos x. Now what is your f dash of C, which is nothing but cos C? Your condition is your f dash of C should be equal to 0. That means cos C is equal to 0, which means C is equal to pi by 2, which is in the interval 0 to pi. Again, this Rolle's theorem is verified. That is, you have to write this Rolle's theorem holds for the function f of x is equal to sin x. And now coming to this third question. Here f of x is equal to mod x. This is a continuous function. Since your mod x graph looks in this way, this is a continuous function. This means your first property gets satisfied. And now coming to this, here you can clearly say that your f of minus 1, which means mod of something negative value, which gives you minus 1, and f of 1, which is positive value 1, this both are not getting equal, right? So this Rolle's theorem does not hold for f of x is equal to mod x. Okay, and now this is your another question. Verify Rolle's theorem for the function f of x is equal to x cube minus 3x square minus x plus 3 in the interval 1 comma 3. This is also same as previously how you made it. Since you know that this is a polynomial function, it is continuous. That means our first property is getting satisfied, and our second property is to find f dash of x, whether it is differentiable or not. See, it is 3x square minus 6x minus 1. That means it is also differentiable. And now coming to this third property, that is f of 1 should be satisfied. That is 1 cube minus 3 into 1 square minus 1 plus 3, which gives you nothing but 0. And now coming to f of b, that is f of 3, that is 3 cube 27 minus 3 into 3 square 27 minus 3 plus 3, which is again 0. That means your f of 1 is equal to f of 3. These three cases are also satisfied. Now there exists a point such that f dash of c should be equal to 0, right? So on equating this f dash of c to be 0, what is your f dash of x value? 3x square minus 6x minus 1. That means your f dash of c is equal to 3c square minus 6c minus 1, which is equal to 0. And you know how to solve this, right? That is c is equal to minus b plus or minus square root of b square minus 4ac by 2a, which is nothing but 6 plus or minus square root of 36 plus 12 by 6, which is 6 plus or minus this is nothing but your 48 by 6. Now you can write this 48 square root of 48 as root of 12 into 4, which gives you 2 into root 12. Again this can be written as 12 4 into 3. That means it is nothing but 4 root 3. That is 6 plus 4 root 3 by 6. We can further write it as 1 plus or minus 2 root 3 by 3. So on solving this, you will get as 1 is equal to, this f dash of c is equal to 1 plus or minus this value. We know that the value of root 3 is 1.732 into 2, which is nothing but 2 into 2 4, 2 3 is 6, 2 7 is 14, that is 2 1's 2, 3.464 by 3, which will gives you approximately 1.154, and now if you can see, that is 1 plus 1.154, which is nothing but 2.154, which is in the interval of 1 to 3, right? So this Rolle's theorem is also satisfying with for the function f of x is equal to x cube minus 3x square minus x plus 3. Hope you're clear with this, and if you have any doubts regarding these problems, please feel free to ask me in comment section. And now coming to another question. Here your f of x is again polynomial function, which means it is continuous. That means your first condition is being satisfied, and your second condition is to check whether it is differentiable or not. Here you will get your f dash of x, which is nothing but 2x cube, which is 2 into 3, 6x square plus 2x minus 4. And our third condition is nothing but your f of a should be equal to f of b. Now your f of a, which is nothing but f of minus root 3, which is 2 into minus root 3 whole cube plus minus root 3 whole square minus 4 into minus root 3 minus 2, which is 2 into minus root 3 whole square, which is 3 into minus root 3, you will be left over with minus root 3 plus minus root 3 whole square, which is 3, and then plus 4 root 3 minus 2, which is 3 minus 2, 1, minus 6 root 3 plus 4 root 3, which is 1 minus 2 root 3. This is the value of f of minus root 3. And now check for the value of f of root 3, which is 2 into root 3 whole cube plus root 3 whole square minus 4 into root 3 minus 2. This is nothing but your 6 root 3, and this is 4 root 3, and this is 3 minus 2, which is 1, which is 1 plus 2 root 3. Here your f of a is not equal to f of b. That means Rolle's theorem is not satisfied for this polynomial function f of x is equal to 2x cube plus x square minus 4x minus 2. By now you have I think that you may got clarity on how to solve this questions of Rolle's theorem. And let us go through the another question. Now your f of x is given as log of x square plus ab by log of x into a plus b. In order to make this differentiation simple, we can write, see, this is in the form of log of a by b, which can be written as log of a minus log of b. However, we know that this function is a continuous function. Now we can write this as log of x square minus ab minus log of x into a plus b. And since we know that log of ab, which is nothing but log a plus log b, we are applying that property again here. This can be written as log of x square plus ab minus log of x plus log of a plus b. And now let us differentiate this function f of x. Now this is your f of x, and the differentiation of this is log of x, which is nothing but 1 by x, and inner derivative of this is 2x minus log of x, that is 1 by x, and the derivative for this constant, which is nothing but 0. And since it is continuous and then differentiable, that is, this is your f dash of x, right? And also you have to check for the value of that is whether your f of a is equal to f of b or not. Now your f of a, which is nothing but log of a square plus ab, log of a square plus ab, this is your f of x, right? Now this is your f of x, right? Now your f of a is log of a square plus ab minus log of a into a plus b. As you can take a common here, a into a plus b minus log of a into a plus b. Since this both were same, your f of a is equal to 0. In the similar way, f of b is equal to log of b square plus ab minus log of a into a plus b, which can be again written as log of, if you take b as common, b plus a minus log of b into a plus b. Again, since this both were same, now your f of a is equal to f of b. Now you will check for the condition, that is your f dash of c should be equal to 0. Now what is your f dash of x? Your f dash of x is nothing but 2x by x square plus ab minus 1 by x. Now your f dash of c is 2c by c square plus ab minus 1 by c, which is equal to 0, which can be written as, now from this you can on cross multiplying, 2c square equal to c square plus ab, and 2c square minus c square, which is nothing but c square equal to ab. C is square root of ab. Always this will be in between a and b, so the Rolle's theorem is verified. How can you say that this is in between a and b? Let us take a is equal to 1 and b is equal to 2. You can take as of your wish. Now root of 1 into 2, which is nothing but root 2, which is 1.414. That means for the value of a and b, the square root of ab is between this a and b only, right? That means your Rolle's theorem is verified for this function also. And now coming to the another question, that is f of x is equal to sine 2x by e power 2x. Given function is f of x is equal to, we can write this e power 2x as e power minus 2x into sine 2x. Since this both were continuous functions, this entire function is continuous function, and now we are checking for the condition whether it is differentiable or not. Since we are given that is f of x is equal to this, and now your f dash of x is equal to, let us suppose this to be u and this to be v, u into d by dx of v plus b into d by dx of u, which is nothing but e power minus 2x into d by dx of sine 2x, which is nothing but cos 2x, into inner derivative of this 2x, which is nothing but 2, plus sine 2x into d by dx of e power minus 2x, which is nothing but e power minus 2x, and inner differentiation of this minus 2x is minus 2, which is nothing but 2 times of e power minus 2x into cos 2x minus 2 times of e power minus 2x into sine 2x. Since we know that this is continuous and this is differentiable, now we check for the condition whether f of a is equal to f of b or not. Now f of 0, which is nothing but e power minus 2 into 0 into sine 2 into 0, which is nothing but sine 0. Sine 0 is 0. And now again while checking this f of pi by 2, it is nothing but e power minus 2 into pi by 2, 2 into 0, e power anything, that is anything power 0, which is nothing but 1, right? And now into sine of 2 times of pi by 2. This pi get cancelled, 2 get cancelled, and the value of sine pi is again 0, right? So your f of pi by 2, which is equal to 0, and f of 0, which is also equal to 0. That means your f of 0 is equal to f of pi by 2, which is equal to 0. That means your f of a is equal to f of b. Your third condition is also satisfied. Now you have to check whether this whether you have a point c in this interval or not. For this, your f dash of c should be equal to 0. This is your f dash of x value, right? Now your f dash of c is nothing but 2 times of e power minus 2c into cos 2c minus 2 times of e power minus 2c into sin 2c, which should be equal to 0. Here this both are common, right? So it can be cancelled. Now cos 2x is equal to sin 2x, because cos 2x minus sin, that is cos 2c minus sin 2c equal to 0, right? So cos 2c is equal to sin 2c. Now if you send this cos 2c here, your tan 2c is equal to 1. We know that at theta is equal to pi by 4, your tan that is at tan pi by 4, you'll get the value of 1, right? So on comparing, now you get 2c is equal to pi by 4, c is equal to pi by 8, which is in the interval 0 comma 2. So this Rolle's theorem is again satisfied for the function f of x is equal to sin 2x by e power 2x. And now let us go through our last question of this topic. Guys, I hope you are getting it, and if you still have any doubts, I'll discuss this question again in a very detailed way, step by step, from the very basic, if you have any doubts, so that you make it clarified. Okay, since see here you have to verify Rolle's theorem for the function f of x is equal to e power x into sin x minus cos x. See, I'll write step by step. Here we know that this is already a continuous function, because sin x is a continuous function, cos x is a continuous function, and e power x is also a continuous function. Since all these were continuous functions, the combination of this is also a continuous function. That means your first condition, that is f of x is continuous. So whenever we get in the question to verify a Rolle's theorem, our first step is to check whether it is continuous or not in the given interval. Okay, so f of x is continuous in closed interval pi by 4 comma 5 pi by 4. And what is our second step? Our second step is to check whether f of x is differentiable or not. Since our f of x is equal to e power x into sin x minus cos x. We can write this as e power x into sin x minus e power x into cos x. Now your f dash of x is on applying UV rule, that is d by dx of e power x into sin x minus d by, for this you will apply UV rule, d by dx of cos x. Let us suppose this to be u and this to be b, which is nothing but u into d by dx of sin x plus v into d by dx of e power x minus, again apply UV rule for this also, that is u is nothing but your e power x, right? E power x into d by dx of cos x plus cos x into d by dx of e power x, which is nothing but e power x into d by dx of sin x is nothing but your cos x plus sin x into d by dx of e power x is nothing but your e power x, minus this is e power x into d by dx of cos x minus sin x plus cos x into d by dx of e power x, which is nothing but your e power x, which is e power x into cos x plus e power x into sin x, minus of minus, which is plus, so e power x into sin x minus e power x into cos x. Now this minus e power x into cos x and plus e power x into cos x get cancelled. Now your f dash of x is equal to 2 times of e power x into sin x. Since it is differentiable, we have to write that f of x is differentiable in, no need to write closed interval, this already indicates closed interval, is differentiable in open interval pi by 4. Oh, you are unable to see it. F of x is differentiable in open interval pi by 4 comma 5 pi by 4. And our third condition is to check whether f of a is equal to f of b or not. For that, see, whatever interval given, the first one represents a and the second one represents b. Now your f of x is nothing but e power x into sin x minus cos x. Now what is your f of pi by 4? It is nothing but e power pi by 4 into sin pi by 4, e power pi by 4 into sin pi by 4 minus e power pi by 4 into cos pi by 4. Since the value of sin pi by 4 and cos pi by 4 both are same, it gives you 0. And your f of b, which is f of 5 pi by 4, which gives you f of 5 pi by 4, 5 pi by 4, which is e power 5 pi by 4 into sin of 5 pi by 4 minus e power 5 pi by 4 into cos of 5 pi by 4. Since again it is the multiple of this pi by 4, this both values are same and it is 0. Since your f of a is equal to f of b, that means, see, firstly you have to check whether it is continuous or not, and second whether it is differentiable or not, and at last f of a is equal to f of b or not. If these three conditions are satisfied, then only you have to check whether there exists a point c such that your f dash of c is equal to 0. See, here you will get the value of f dash of x by differentiating. Now in place of that x, you have to just substitute c for this f dash of c. So your f dash of c, which is nothing but 2 times of e power c into sin c, which should be equal to 0, right? So e power c into sin c is equal to 0. As if you can observe here, your e power c can never be equal to 0. Okay, so your sin c should only become 0. So your sin c equal to 0 means it can be 0 for every integral multiple of pi, right? So c can be plus or minus pi or plus or minus 2 pi or plus or minus 3 pi plus and so on. But they have asked to verify whether this Rolle's theorem gets satisfied in the interval of pi by 4 and 5 pi by 4 or not. If you can see here, among this only plus pi is the one which lies in between pi by 4 and 5 pi by 4, right? So just if at least one point gets satisfied, that is, if there exists one point in the given interval, then also the theorem is getting satisfied. So for c is equal to pi, okay, which belongs to this interval, right? Since c belongs to pi by 4 comma 5 pi by 4, our Rolle's theorem gets satisfied. This is how you solve the questions of this Rolle's theorem, and by now hope you have got so much clarity on how to solve, because we have discussed a lot of questions. And still, if you are feeling difficult in solving questions, or if you want a little bit harder questions, or whatever you feel, please ask me in comment section. And if you want me to go slower or a little bit faster, and or if any improvements to be made from my side, please tell me in comment section so that I can correct and improve myself. And subscribe my channel for more videos only if you like the content, and also share for your friends if you feel that this video will also help them. And subscribe my channel for more videos.